Hey, in this video, we're covering the basic of how to find where an angle is. You're pretty good with finding angles when it comes to angles in degrees, but when it's radian, because it's a new concept, um, let's say I have to draw some angles and they're all listed in radians. Let me start off with basic. Here's an angle. This is listed in radians. I need to find where that angle is. I need to draw its initial side and its terminal side. So I'm going to use my circle here. Also, don't forget, every single time we must know that's 0 radians, that's pi radians, and one complete circle is 2 pi radians. So the way I want to read this, like I said in class, I would rather read this as 2/3 of a pi, which means pi is split into 3 parts, and I need to get to the second part. Now, pi is only these first top 2 quadrants. Just the top 2 is pi radian. So the top portion needs to be split into 3 parts in total. And you can continue this, because that way we have our first part here, which automatically means pi over 3. This means second pi part, so 2 pi over 3. This leads to 3 pi over 3, which is back to pi, 4 pi over 3, 5 pi over 3, and back to 6 pi over 3, which is back to 2 pi. And it completely makes sense, because 1 revolution is 2 pi. So here's a split. Not only here, you can locate a 2 pi over 3 angle, which is what the question was. We can locate way more than that. Use a different color. So 2 pi over 3, here's the initial side. Initial side doesn't move. And 2 pi over 3 goes right here. And that's an angle, a positive 2 pi over 3 angle. Also, 2 pi over 3, if you were to convert it quickly into degrees, pi refers to 180 degrees over 3. This goes into it 60 times. It's a 120 degree angle. And like I said in class, if I were to ask you to draw a 120 degree angle, in a second you would know that's going to be in the second quadrant, not the 2 pi over 3. So here's one basic one. Let's move on. What if I'm asked to construct a negative 2 pi over 3 angle? We're still splitting pi into 3 parts. Right? This is 0, this is pi. The only thing is I'm now going clockwise direction, right? This is the negative direction when it comes to angles. So still 0 to pi is split into 3 parts. Part 1, 2, 3. And then if I continue, it's 4, 5, and then back to 6. So negative 2 pi over 3 would be this one, negative 2 pi over 3. And the angle constructed would be, here's the initial side of the angle. And I went this way. And here's the terminal side of the angle, and this clearly defines the angle. Negative 2 pi over 3 radians is the angle measurement. Now do me a favor, look at question 1 and question 2. One was a positive 2 pi over 3, and the other one's a negative 2 pi over 3. This was positive 2 pi over 3, if I were to use red for positive, which was located right here. This was positive 2 pi over 3 angle. And the white one is a negative 2 pi over 3 angle. If you look at it carefully, they're reflections of each other over x-axis. These two are reflections of each other over x-axis. And that's how positive negative angles are. Which means, if I were to make a conclusion on that, if this is a 150 degree angle going this way, negative 150 degree would be nothing but a reflection of 150 over x-axis. The reflections are constructed over x-axis. This would automatically be a negative 150 degree angle. Just saying. All right, let's construct a few more. Let's say, whoa, this one's asking me, hey, construct an angle that's 17 pi over 4. Where does that belong? Which quadrant does that belong? And like I said, I would read this as 17/4 of pi, which means pi is split into 4 parts. And I need to get to the 17th part. 0, pi split into 4 parts. Oh, that's beautiful. It'll be, half will be right here, so this will be a 4th, and that'll be a 4th. And if I continue, these are all 4ths. Yay, right? 1 pi over 4, 2 pi over 4, 3 pi over 4, 4, 5, 6, 7, 8. And you can clearly see 17 is more than one rotation. Right, half rotation 4, and then 8, plus 4, 12, plus 4, 16, and one more. There we go. This is 17 pi over 4, which basically we're back to pi over 4. if I were to label that angle, that's the initial side and that's the terminal side. So 17 pi over 4 angle is located at the same location as pi over 4. Like value-wise, they don't equal. Like obviously this does not equal that. I'm talking about location here. The location is the same. They're coterminal angles because their initial side, pi over 4, the initial side and terminal side of both pi over 4 and 17 pi over 4 is the same. It's just that 17 pi over 4 is multiple rotations. Two full rotations. No, actually we rotated 4 times, right? That brings me to this point. Can I not write this as 16 pi over 4 and then another pi over 4? Right? I could split it like that. And this is 4 pi. And 4 pi refers to 2 rotations. So 2 full rotations later, we end up at pi over 4. That's another way to look at it without having to go round and round. Okay, let's look at negative 17 pi over 4. Technically, you can find 17 pi over 4 first and then just reflect it. So my 17 pi over 4 was here, right? At the location of pi over 4. Negative 17 pi over 4 is going to be a reflection of it right there. Negative 17 pi over 4. So this angle is going to be right here. Here's the initial side, and here's the terminal side. And of course, we went 2 full rotations, boom, and then a quarter more to get to that angle. Now, I know I did that very fast because we just found 17 pi over 4. So I reflected it over. If we were to do it step by step, then same thing. Split 0 to pi in 4 parts and get to the 17th part, but going clockwise. And I'm splitting it in 4 parts. Correct? So that's pi over 4, but in negative direction. So I can't write pi over 4 actually. I'm just going to write it parts. 1, 2, 3, 4. So clearly that's 4, 8, 12, 16, and 17th part right there. Initial side of the angle, terminal side of the angle. And we went round and round and round. 2 full rotations and another pi over 4 location later. We ended up at negative 17 pi over 4. And to tell you, this is the exact same location as negative pi over 4. Okay, we need to be able to locate so we can actually find the sine value there or the cosine value there or the tangent value there. So this video was dedicated to just finding a radian angle. Hopefully that was helpful. See you in the next video. Bye.